Good morning, everyone. Due to some technical issue, we will start in 5 to 10 minutes. There are some technical issues, and we will start after 5 minutes. Okay. Sorry for the inconvenience.
गुड मॉर्निंग सर.
हाँ, गुड मॉर्निंग राही जी. एम आई ऑडिबल? मेरी आवाज मिल रही है?
यस सर.
Okay, so now we shall start the fifth lecture
यस सर.
under the Platinum Jubilee lecture series. There was some problem in the other computer from the computer lab which we have in the department, so that's why I am using Bhavuk ji's laptop for initiating the program, and then we will see rectify the problem there in the other desktop.
Yes.
I can see that around 48 participants are there in this Platinum Jubilee lecture. Our dear student Akhouri Biswapriya ji, are you there?
Yes, sir. Good morning, sir.
Good morning. Good morning. So we are delayed by say 5 to 7 minutes, but I think we must start the Platinum Jubilee lecture series. Yes, Vishwapriya is well ready. So let me formally start the Platinum Jubilee lecture series, which is fifth in the series. Good morning, everyone. We have with us the students of our department, the alumni of the Department of Geology, joining from various corners of the country. I think we are also having officers from the Geological Survey of India. So on behalf of the Department of Geology, the students, faculty member and staff, I welcome you all in the 5th lecture under the Platinum Jubilee lecture series of the Department of Geology. As you all know that the Department of Geology was established in 1946, and we are having 75th year and celebrating the achievements, the past glory of the department. And under the program, there are several items which we have kept, where Platinum Jubilee lecture series is one very, very significant and important segment of the Jubilee celebrations. Monthly, we are having one lecture by eminent geoscientists from our department, from elsewhere also. And as I informed you that this is 5th in the series, just recalling that the first lecture in the month of August was delivered by renowned hydrogeologist Dr. Dipankar Saha. In the month of September, we had a very nice presentation by renowned sedimentologist Dr. Rajiv Sinha, the chairman of the Earth Science Department at IIT Kanpur. The third lecture was by Pranay Lal, who shared magnificent and beautiful points regarding to the paleontological evidences and evolution of the life forms. And the fourth was again by the alumnus of our department related to GIS and its applications. So this is the 5th lecture by Akhouri Biswapriya. I have shared that he is director in the Geological Survey of India, State Unit Bihar. The topic which was shared earlier, that he'll be talking about geology of Bihar, but last night we had a discussion and there is slight modifications, not modification they said, because some addition to it, whatever the GSI has done to understand and unravel the geology of Bihar during the recent past, Akhouri Biswapriya will be talking about. I must thank the Geological Survey of India, State Unit Bihar, because the department is very closely connected with the GSI, whether it is the help for the research scholars of our department, whether getting some ideas and training for the postgraduate students. Recently, the postgraduate 4th semester, final semester students, they have undergone 2 days of intense field training at the Dumka Devghar area, where the officers of GSI, they have contributed a lot. So with these words, now I request our dear students, very versatile personality, Akhouri Biswapriya, very closely related to the activities of the department, and the department is also well connected with GSI through eBhuvi Samvad and other activities. So we are happy that alumnus of our department is here with us for the 5th lecture under the Platinum Jubilee lecture series. Over to you, Biswapriya.
Well, thank you very much, sir. Thank you very much for your kind words, rather very encouraging words, which you just expressed from your side. Yes, I'm equally delighted to be a part of this Platinum Jubilee celebrations of Department of Geology, Patna University. And first and foremost, I would like to thank Dr. Atul Aditya Pandey, Professor and Head of Department of Geology, for giving me an opportunity to be a part of this lecture series, which is 5th in the sequence that I just came to know. And obviously, I've been following the other lectures also, which have been done in the past. And it's a welcome opportunity for me to be interacting with the wonderful students of this department. And also, I extend my good wishes and regards to all the alumni members who are a part of this group, wherein this program was flashed. And of course, I feel extremely happy and delighted to be a part of this 75 years of service of the department in bringing about so many wonderful students who are doing so well in their various spheres or the arena of work that they are continuing, including academics, profession, and otherwise. Well, as rightly said, yes, we did have a discussion. Initially, I had to talk about the geology of Bihar per se, but as I represent a very big organization which has a history as long as 170 years, even more than that, it would be rather wise and prudent of me to be discussing the perspective of Geological Survey of India as an organization and how it has worked over a period of time. Because if we look into the structure of this organization and the time it has seen, it has been a very long episode. And when we talk about the milestone of independence, so its presence is actually etched in the sands of time on either side of the independence. So it was founded way back in 1851, and now it's been we are into almost into 2022. So it's a very long history. So a lot has been done prior to the independence also, and a lot was done after independence. So of course I'll be emphasizing on the geology of Bihar, but yes, per se, I would like to concentrate more on what GSI has done in terms of its recent activities, particularly in context of the rather unceremonious segregation of erstwhile Bihar into Bihar and Jharkhand that happened in the year 2000 on this 15th day of November, when the two states were divided and most of the mineral-rich provinces or the stratigraphic provinces which supports mineralization or the rock exposures went into the side of Jharkhand. But yes, that gave us a perspective to look into the whatever remained with us, and obviously we have come up with a lot of findings in the last few decades. So obviously my entire onus will be on that. So if you permit, sir, I'll go ahead with the presentation.
Yes, you may continue, please.
Yes, sir. Just give me a minute. I'll just load the presentation. Yeah. Okay, is the slide visible to all, sir?
Yes, the slides are visible. Yes.
Okay, so this is it. This is my opening slide. As you can see, we are into the Platinum Jubilee Celebrations Department of Geology, and we are celebrating 75 years in service to science and education. And this is what my topic looks like: activities of Geological Survey of India as nodal geoscientific organization. This is very important because we are the nodal geoscientific organizations. Whatever ancillary organs, whatever geological work is being carried out by other organizations, per se happens to be a bifurcation or the offshoots of Geological Survey of India, if you might like to think like that, because the initial expertise has been shared by Geological Survey of India. Now, of course, there has been a lot of offshoot, but essentially GSI is the nodal geoscientific organization of the country. And I'll be talking that with respect to geological framework of Bihar and its present day activities that will include a gamut of activities that we've been doing. So I start at 11:45, sir, and I think I'll be taking around 1 hour time to do justice to my presentation, sir. If I just extend a little bit more than that, sir, please do bear with me. But I'll try to hurry up with most of the slides, which is more of a picturesque nature, which is just elaborative, illustrative, rather than the subject matter. But yes, it is an exercise basically to involve, help students pick up the nuances of all that GSI is doing and what it is doing in context with the interface that it has developed with the Department of Geology as well. So next slide. Okay. So at the beginning of this decade, that is 2020, we started making a vision plan called 2030. Of course, it is still in its states of nascency, and we are going to finalize it very soon, sir. But as I was quite instrumental in it, we have kept a tagline or the basic motto of vision, which is reaffirming unwavering commitment to a holistic and sustainable growth in geosciences. Now, this became even more applicable in the event of this 36th IGC, which was supposed to be held in India, but because of the pandemic reasons, it had to be postponed, and finally it was not held, and that was rather unfortunate. But yes, we have drawn a vision for 2030. A number of programs have been lined up according to that, and that is something that we need to know. And had this program held, that would have opened new vistas of commitments and opportunities that lied ahead of us in terms of the decade planning that we are doing. Now, well, a little bit of historical perspective is very important as far as our organization is concerned. And that I feel is also important for me to share at this point in time is because all these students who are at the verge of leaving the academia and will be trying for professional entries into various organizations, including GSI, they must have some information about organization as such, which Geological Survey of India is all about. So if we look at this, the Geological Survey of India, I would say it's a premier geoscientific organization. It is one of the oldest organizations in the world. And it is presently an attached office of Ministry of Mines. And its origin can be traced way back to 1836, when the East India Company was trying to explore coal deposits, particularly for the purpose of railways. Now, this was a basic purpose, but formally on 1851, on the 4th day of March, it was founded when Sir Thomas Oldham was the first superintendent and of a Geological Survey of India. Today, if we look at the basic charter of GSI, that includes providing objective and impartial and up-to-date geological expertise and information of all kinds. Now, this can be on the focus of policy-making decisions, commercial and socio-economic needs. Well, it also emphasizes on systematic documentation of all geological processes derived out of surface and subsurface of the country's land and its offshore areas. Now, by offshore areas, I mean that exclusive economic zone, that we go into the territorial waters also, that we carry out investigations, and that form a major part of our activities. Now, if you look at the core competency or the expertise that lies within GSI, it basically is in survey and mapping, and it is continuously enhanced through accretion, management, coordination, and utilization of spatial databases. And it also functions, having collected all this useful data through extensive sampling and mapping, that it acts as a repository or clearinghouse for the purpose, and it uses latest technology in terms of computer-based technology for dissemination of geoscientific information in spatial database. So this was the basic charter with which it was found. Well, I'll quickly go into I'll request all present here, particularly the students, to have a look at these wonderful memories, or rather wonderful pictures that will help you go into the past, how this organization came into being. And I'll quickly go with these slides, although it is not relevant as far as Bihar is concerned, but yes, it is very important in context of this organization, how it has unraveled the geological framework of the country. Well, if you look at the A map, it was basically in 1780 that East India Company started spreading its wings, and Calcutta became the hub of operations. If you look at B, well, there was a basic need. Even during the colonial era, there was a basic need to strengthen the backbone of economy, and that lied within the huge mineral deposits that lied within the country, which were not explored as such, and therefore that gave way to gentlemanly reconnaissance. Now, David Harrow Williams in C, as you can see, was the first Britisher who came to India and was appointed as geological surveyor in 1846. But actually, the main story started in 1851 with the appointment as superintendent of Geological Survey of India in Thomas Oldham. Well, he could rightly be said as the father of Geological Survey of India, and he has done exemplary work in terms of whatever we see in front of us. Well, if you can see, in 1877, the first geological map was published based on the preliminary surveys, and as in E, you can rightly see in your screen, this was the first map of the entire subcontinent that was prepared. Now, ultimately, after the coal reserves were found and some of the initial findings were made, it became an exercise for all of us to look into more coal prospects in the country. And likewise, Korba, Rewa, Wardha, Raniganj coalfields were discovered by GSI and its finds. In G, as you can see, the first iron ore in 1904 was discovered by Sri P.N. Bose, which changed the course of Tata Steel fortune. And he also remarked, Mr. P.N. Bose, that Mahesani Hills were a treasure for iron ore. Now, this was a big statement during those times because, see, when you find out a deposit and you say this place is particularly very rich in deposit, that becomes a headline. So that was a headline during those times, and obviously that led to many other discoveries. Now, if you look at the kind of reconnaissance or the kind of fieldwork that happened during today is exemplified in figure H, which clearly says that people had to do most of the exercise with barefooted, and horses, animals, and elephants, and other things were available. But it was extremely difficult. Once you were out of your house or out of your camp or organization, you were in God's good humor. And it was very, very strenuous and very, very exerting fieldworks that had to be carried out during those time. Now, we'll quickly look into the main stories, how they unfolded with the passage of time. Tata Steel in 1911 started producing pig iron based on the discovery of Geological Survey of India. Now, the major commodities, major mineral ore commodities in iron, manganese, copper, lead, zinc, aluminum, uranium, and gold also was discovered likewise, and the type provinces were identified also. Aluminium industry, which was very, very important for the economy of the nation, was started in 1943, and mica mines, particularly with sillimanite, kyanite, were the major non-metallic finds of Geological Survey of India. Now, if you look at this photograph, this is a very suggestive photographs in the sense that there was just a handful of Britishers, and they were aided by some Indian help also at that time. Obviously, they had the major domination in terms of the expertise that they carried to India, and these were the people who on which is coronated the entire achievements of the first 50 years. And it can be summarized that only 11 geologists covered the entire subcontinent, 5.7 million square kilometer. But these handful laid the strong foundation of the geology of Indian subcontinent. When we see so much of work was carried out in 50 years with such limited strength, we wonder how much was accomplished by so few. So that was the basic need of increasing the strength of Geological Survey of India with passage of time. And as you can see, more number of coal fields were found, particularly the Gondwana coal fields. And as you can see in the screen, W is for 5 major workers or scientists: Hayden, Pascoe, Firma, Holland, Heron, Hayden, made significant contributions to the geology of the country. Now, some of the morphostratigraphic sequences which we understand and read in our study books today, particularly the Windians, the Tertiaries, the Himalayas, and Khasi Jaintia Garo Hills, those parts of extrapeninsular region, all were slowly and gradually identified with the passage of time. Now, as you can see, the Everest expedition also started in terms of knowing the geology of that region, and Thomas Oldham made a major initiative as far as that is concerned. Now, the Jharia and Bihar Mica belt in Bihar, particularly by Dan and Christian, that was founded. So it was a significant find of Geological Survey of India, and which the country till date is banking for its reserves. Now, gradually it diversified into other fields of expertise also. For example, the Kachar earthquake, the Great Assam earthquake, and the requirements of engineering geology that basically emerged out of the requirement of railway line extension in Raniganj coal fields. That engineering geological investigations also came into play. Now, in 1935, this geophysical wing, which is an ancillary and supportive unit of Geological Survey of India, and very important in unearthing deep-seated deposits and deep-seated investigations with the help of various geological survey, with the help of basic survey tools, was started by A.D. Saw, Al Carlo, Ramachandra Rao in 1935, and that opened a new chapter as far as India was concerned. Now, just after, on the other side of independence, Mr. M.S. Krishnan in 1951 was appointed as the first director of Independent India of Geological Survey of India, laying foundation of this great organization in post-independence era. Accordingly, various river valley development projects, multi-purpose projects like Hirakund, Bhakra, Teri Dam, all these investigations started, and the backbone lied in geology, whether it was overburden or rock. It was basically on the basis of systematic investigations that GSI made its importance felt in all these multi-purpose projects, drawing a good collaboration with the engineering fraternity. With the GSI's focus primarily on mineral finds in the post-independence period, most of the sister organizations emerged out of the bench strength or the expertise which lied within this organization. And gradually all these great organizations that we know in present day, like the Central Groundwater Board, the Indian Bureau of Mines, the Mineral Exploration Corporation Limited, the Coal India, etc., all these came into existence, but were basically offshoots of this great organization, and they emerged out of the expertise which lied in Geological Survey of India. So that was it. Just a bit of nostalgia going into the past, because that is something which really excites me all the time, because the kind of hard work that has been drawn on either side of the dates of independence has been exemplary, and I don't think it would have been possible without the sacrifices these great men have done in terms of unraveling the geology of the country. Now we come to the present context, which is very important for us to understand, because this is the charter with which GSI works. So this is important because this might be asked in some of the examinations that you might take up in a new course, and this will help you to draw the charter of GSI. So basically, first charter is systematically documenting geology and geological processes of the surface of India and offshore areas, and that it does with the help of techniques and methodologies, including geological, geophysical, and geochemical surveys. Second is to explore and scientifically assess mineral, energy, and water resources, and this is done with the help of airborne, marine, and hyperspectral surveys. It also also functions as a repository and disseminates geoscientific information. Now, if you imagine, almost 1,200 items are being done, and each item, if you say, covers an area of about 800 kilometers or 700 kilometers. So the kind of data which is being generated out of an area has to be properly stored for later retrieval, and that becomes a very important piece of information for the beneficiary agencies. So that becomes one of the important aspects of work of GSI. If you look at the fourth point, which is imparting training, yes, we have a training. It forms a part of the charter of GSI. We have a training institute which comes in the Mission 5 activity, and it imparts training not only to the in-house strength, but also to academia, various other organizations. And there is a huge gamut of people who are coming from abroad, from other countries with which GSI strikes a collaboration. And these people also taking field-based training and headquarter-based training at various training institutes of GSI. So that's a very important aspect. Now, if you look at the multidisciplinary and fundamental geoscientific research, that comes under the gamut of Mission 4 activities. And through it, it looks into various issues like landslide, earthquake studies, microzonation, geoenvironmental studies, and so on and so forth. Now, it also acts as actively participates in international collaborative projects for better understanding of the Earth. It popularizes geoscience at various levels to increase public awareness. Yes, I'll be coming into detail. As you can see, through the forum of Bhuvi Samvad, we reached out to various universities, particularly Patna University, and so many other areas, which helped people know about the activities of GSI and also its contribution in nation building. And finally, if you look at the impartial and up-to-date geoscientific expertise, yes, we have a Mission 3 activity. This helps in conservation of natural resources through geoparks and museums. Yes, geoparks and all these natural finds in India that has to be preserved under the Monument, Geoscientific Monument Act. And there are 32 such geomonuments as far as India is concerned, and we are constantly on the efforts of increasing that number. And that is something that we need to travel to and know about the chapters or the pages of Earth, how they have unraveled. Now, as far as international collaborations are concerned, yes, GSI participates in bilateral cooperation and collaborative programs through understandings with several countries of geoscientific issues. And if you may like to understand it this way, that it is a unique cooperative enterprise, and UNESCO and IUGS, which is International Union of Geological Sciences, has been stimulating comparative studies in the field of earth sciences since 1972. So on the screen that you just see is just an example of few of the IGCP programs that have been held in the past. And the Indian National Committee for IGCP is the apex body for all IGCP activities. And GSI per se has completed more than 120 to 150 projects, of some of which are displayed there on the screen. So coming on to the next slide, yes. Now, of late, in 2007, GSI started working on a mission matrix mode, and it is not a mixed way that it is now working. It is now compartmentalized or segregated most of its activities across missions. So that is the main idea of GSI, and now they have been categorized into 5 missions. So I'll just quickly run through it, because mission 1 is identifying a virgin area and carrying out baseline geoscience data generation that can be done with the help of ground survey, geological, geochemical, geophysical survey, marine coastal survey, geotechnical survey, and that is aided with the help of remote sensing, aerial survey, geomorphological survey, hyperspectral survey, and so on and so forth. And once this basic data is generated and some area turns out to be encouraging, then we go on to the mission 2 activities, which deals with the natural resource assessment, and there are various stages of exploration with which we work. And of course, the main idea is to find out the natural energy resources. Mission 3, as I rightly said in the beginning, we need to have a very strong wing of geoinformatics that not only preserves that data, not only feeds that data, but that data repository management system has to be made available to the user agency. So we use basic technologies also that help us doing so. And fundamental and multidisciplinary geoscience comes under Mission 4. All these aspects of natural hazards like earthquake and landslides and biogeochemical hazards and urban town planning and so many other activities where GSI has a contribution to play that has been done that gets covered under Mission 4. So we have isotope geology, geochronology, meteorite, planetary studies, polar studies. And finally, Mission 4 is to do with the training and capacity building, which I just talked about, and I'll just go into detail a little bit in the following slides. And to support all these 5 missions, we have scientific and technical support system, administrative support system, and policy support system. So policy support system is basically to do with the planning and monitoring. Administration is to do with money matters, finance, personal, legal cell, parks and museums, states, etc. And scientific support system is that we have a very strong and robust drilling, in-house drilling system. We have transport, survey, code library, and all that. So this in turn, this entire screen that you're seeing is a consolidation of activities of GSI per se. And of course, apart from this, also many things are covered, which I'll be going into detail. So this is a picturesque illustration of how the Mission 1 activities. In the first row that you can see, survey and exploration within offshore and onshore areas, how it is being carried out. Landslide and fundamental geosciences, how that is looked into, and finally paleontology. And all these aspects that you study in your textbook is something that you deal with in detail as you get into the organization. So I'll just quickly go into the activities of Mission 1. If you may understand, systematic geological mapping was basically a program which is drawn up to resolve some interesting or intricate geological problems with a view to updating geological knowledge, as well as to locate prospecting areas of mineral deposits and also to target mineralized zones. As you can see, these are some of the facts or figures which are there on the screen. What is the percentage that has been covered as a result of this exercise? Similarly, National Geochemical Mapping, the program was started with me entering into the organization in 2000, and it was in 2001 that it was launched, and creates a national geochemical database of the entire landmass of the country on 1:50,000 scale. It does it with an aim to derive primary information on 66 elements with Clark value as their detection limit. This has first targeted the obvious geological potential areas, which are being prioritized, and of course later on. Similarly, as you can see, geophysical mapping, it is also an exercise in basically gravity and magnetic survey, the primary geophysical tools for understanding the structure and subsurface geology that significantly aids the geological activities. And this was also initiated in 2002, 2003, and the entire area that you can see in your screen has been covered. Now, if you look into Mission 1B activities, this basically has to do with remote sensing and aerial survey. It carried out multi-sensory airborne geophysical surveys since 1965 to harness the minerals and mainly base metals, lead, zinc, and copper, which is there. And the systems that we have in place is Twin Otter Airborne Survey System, TOASS, which has covered so many square kilometers, as you can see in the screen. Next, you can see Mission 1C has to do with marine and coastal survey. Of course, we have a very strong infrastructural support in RV Samudra Ratnakar, RV Samudra Kostav, and RV Samudra Shadikama, and it does some high resolution mapping of exclusive economic zone of India and beyond. And we have Samudra Kostav also and Samudra Shadikama, the systematic mapping of territorial water zone of India, which is endowed with placer minerals and other kinds of mineral deposits, mainly hydrothermal polymetallic sulfide deposits. Exploration is done in collaboration with Department of Earth Sciences, and these are some of the findings of Samudra Ratnakar. It has achieved a tune of 47,877 million tons of Gujarat coast of lime mud of thickness of 22 meter. Phosphorite around Chennai, Karwar, and Mangalore has also been found out as a result of this exercise. We have also been able to find out within the Lakshadweep Ridge and iron manganese mineralization around Andaman. That is some of the findings. If you see at the probing capacity of Samudra Ratnakar, it's capable of probing up to 4 kilometers below seabed and helps in study of seabed structures and mineralization. So also to satiate the scientific requirements, it can go have a very strong probe of 4,000 meter, and that is something exemplary in terms of expertise that you have. These are some of the photographs which you might like to relish, which is there in your screen. Now, if we look at the Mission 2 activities, as I said, it has to do with the mineral resources or the mineral investigation program. Now, Geological Survey of India is the main agency for geological mapping of mineral resources of offshore and onshore areas, and it has drawn up action-oriented plan in cooperation with central and state government agency. Now, the basic, as per the UNSFC guidelines, it has been divided divided into 4 stages, which is the G4, which is the prospecting stage, the G3, which is the general exploration stage, and G2 is the resource estimation stage. So as you can see in the screen, the discovery of high-level laterite in Andhra Pradesh, copper in Malanchkhand, K3 in Singhbhum, manganese in Sandur, Bunai and Kenjur deposits, chromite, gold discovery in volcanosedimentary sequence, and all these things that you see in the screen. And of course, during the 5-year plan between 7 and 12, these are some of the major deposits which have been founded by GSI. And the pie chart, or the percentage of where they stand in terms of world production and in India production, manganese, iron, base metals, all these are there on the screen. I'll not go into much of detail. Of course, I'll share this presentation if you feel like going into the details. Well, similarly for chromite and other commodities like PGE, gold, industrial mineral, what are the major provinces, what are the tectonic provinces which are supporting this kind of mineralization, whether it's an open cast mine, whether it is a deep-seated mine, where it is all located, what is the production, what is the procedure, all has been dealt with it. Now, if we come into the Mission 3 activities, it has been divided into 3 wings, Mission 3A, 3B, and 3C. It is also known as geoinformatics. Its main function is to build, maintain, and effectively manage the IT resources to ensure archival dissemination of information to various stakeholders and beneficiaries. So it plays a pivotal role in coordinating with the policy support system and also the GSI under its submissions. So Mission 3A, if we see, it deals with the infrastructure, connectivity, and data repository of management. It facilitates integrated IT enabling system called OCBIS. Now, OCBIS is a portal system. Now, this is the common interface which we create with the public. People can have information through the OCBIS, and it is abbreviated as Online Core Business Integrated System, OCBIS. So this is the official portal of Geological Survey of India, and it has been adjusted as one of the best portals for a couple of years, and it is doing fairly well in terms of the plethora of the surfeit of information that lies over there. Now, Mission 3B, if you can see, it deals with the information delivery system, that is publication and library. That is also very important because GSI comes up with several publications like memoirs, bulletins, regards, special publications, paleontologia, Journal of Geosciences, where you can write or contribute your papers also. And this is what we have. So if you look at the figures, we have around 22,000 unpublished reports, 10,000 maps, 1,000 publications, geophysical data sets, mathematical geoscientific data sets, 2D and 3D photographs, and this numbers is continuously increasing with the amount of information that is being generated. Now, if you look at the central library and its capacity, we have 30,000 books, 350,000 journals, and as many unpublished reports. As you can see, this is an earthquake data of 1900 to 2012, and you can see all these red spots or the surface of epicenters that have hit the Indian subcontinent or its parts where earthquake activities are significantly placed. So this is a very good information of how these and what kind of magnitude of earthquakes that have taken place, and we have we sort out these aspects with the help of Mission 3 activities. Now, coming on to the Mission 4 activity, which is also very important. Personally, I have been very closely associated with Mission 4 activities, having worked in engineering geology. As you can see in the flowchart, this is the fundamental geology, geotourism, earthquake studies, landslide, medical geology, and all these aspects which are very, very important in terms of societal, in terms of service to the nation and how people are getting affected because of these natural processes and what GSI does in order to mitigate them, in order to solve problems for them. And under that chapter comes fundamental geology, engineering geology, all these huge multi-purpose projects which serve as the backbone of economy of the nation, is where the basic fundamental geological work in DPR, construction, post-construction stage has been carried out by Geological Survey of India along with the engineers. Medical geology, if you think of it, the fluoride contamination, arsenic contamination, uranium contamination in groundwater, heavy metals, lead, etc., all these are hazardous to health, are looked into by GSI, and Bihar happens to be an important contributor to that in terms of these problems. Landslide studies, obviously not much relevant in terms of Bihar, but yes, there are certain zones in Himalayas, the Deccan Traps, the Nilgiris, all these areas have a gamut of disaster management, forewarning, and site-specific studies, and GSI is continuously does it on a real-time basis, and this is what it does. Now, earthquake studies, Geotourism is also something that is very, very important, and geotourism has come as a new chapter, and we recently came up with a transact around Rajgir area, and we've made a documentary also, which was hugely appreciated at all forums, and we wanted to play it during the 36 IGC, but unfortunately because of the postponement of the event, it could not be done. But yes, now it is available on YouTube, and I will really request Atul sir to organize the playing of that, because now formally it has been released by GSI now. So if you can, it's a 19-minute 50-second program. So if all the students happen to see that, they'll be huge. I mean, immensely excited to be a part of that exercise of GSI Patna. Okay. Now, multidisciplinary geosciences, what are the major aspects? Landslide, engineering geology, volcanology, geochronology. We have polar studies. Of course, we are carrying out polar studies in Antarctica, Arctic, and we have similar programs carried out in parts of Himalayas as well. Geoenvironmental studies, urban town planning, arsenic and fluoride studies, earthquake studies, gem testing. Of course, we are the nodal agency for gem testing programs also. And meteorite. Recently, you would have heard that GSI has that particular meteorite found, Ulkapind, as you can colloquially understand, fell in Madhubani district. Now, Madhubani district, that became a repository of Geological Survey of India later, and it has a very huge collection of 700 meteorites, and it does some classification work also, naming a particular meteorite and where it fell and what is the type area and all that. So we have a very good exhibit in terms of that. So these are some of the pictures where GSI is continuously engaged in terms of fundamental research and engineering activities and paleontology and Gangotri and Bharti Station in Antarctica. Now, this is also something, the in-house capacity or the lab capacity is something that needs to be shared at this point in time. The fundamental geology makes way for research activities, and there are 3 national centers of excellence, as you can see in the screen, which operate from Kolkata, Faridabad, and Bengaluru in fields of petrology, paleontology, geochronology, isotope geology, etc. NGCR Faridabad has facilities like EPMA, Raman spectroscopy, OSL dating, and at Calcutta also we have fluid inclusion studies, meteorite planetary science, gemology, geochronology. Similarly, at Bangalore, we have very sophisticated instruments like X-ray fluorescence spectrometry, mass spectrometry, fluid inclusion studies to do with mantle material and deep-seated rock, and all these studied are carried out. Now, if you look at the Mission 5 activities, yes, it forms a very important organ or core of GSI. As you can see, we have 5 training institutes, regional training institutes, and finally, we have many FTDs and regional training divisions also. And the main objective of Mission 5 is training and capacity building. Now, geoscientists working in all 4 missions need to upgrade their knowledge skills and augment their skills and learn new technologies to enhance the natural resources of the country. Now, GSITI was established for information, I may say, that was established in 1976, which offers a range of training courses like DGMs, PSUs, etc. And it has its headquarters at Hyderabad, but there are many field training centers across India. So you can become a part of it. As Sir rightly pointed out, some of the students of MSc were a part of this exercise, which was done in collaboration with GSI Patna, and some officers shared their knowledge base of working in that area. But that was a one-off experiment or an exercise. But we have established centers where you can get nominated and learn the nuances of geological investigations of field and off the field. So that is a very important information for all of you. Well, these are significant achievement of GSI in the last 10 years or so, and I'll not go into much of detail because that will be overemphasizing on the aspects of GSI right now. But yes, the basic picture I presented. But yes, most importantly is that National Landslide Susceptibility Mapping Program that started with the landslide tragedy, which Uttarakhand tragedy that occurred on the 17th of June 2013. And after that, this program was launched, and now we have covered almost 90% of the subcontinent of India, and it is providing very important information in terms of mitigation and dealing with the problems that we have in terms of landslide. We have also done Project Uncover as a collaborative program with Geoscience Australia, and We have concealed some deep-seated mineral deposits also. This program is very much on now. So apart from that, you see these are some of the commodities, main commodities. I think these are the major minerals like iron ore, bauxite, copper, lead, zinc, manganese, gold, PGE, molybdenum, potash, rock phosphate, and how these productions in million tons have increased on the turn of the century, like 2000, 2005, 2010, every 5 years data we have, and what are the significant achievements of GSI in terms of coverage of land area and onshore areas and offshore areas that GSI has done. Apart from this, we have very good involvement in earthquake activities like SDDRPC, 10 seismodatic observatories in the country, and GSI has set up all these and is constantly monitoring such activities as far as microseismic surveys, microseismic zonation, and earthquake monitoring is concerned. Now, if you look at the revenue generated by GSI over the last 10 years, it's a huge amount, and of course that adds to our credit and something that how we are contributing to the economy of the nation. So that was it as far as the background was concerned. Yes, we would like to see our presence as far as the continent is concerned, subcontinent is concerned, and all these colors basically indicate the regions that we are lying in. So if you see the blue region, that is the eastern region which we are a part of, and our headquarters is at Calcutta. The green region is the area comprising the Jammu, Faridabad, Chandigarh, Uttarakhand, Lucknow, and the headquarters is at Lucknow. Similarly, we have our headquarters at Nagpur in central region. Similarly, in western region, we have our main office at Jaipur. And finally, at Hyderabad is what our regional headquarters is at southern region. As far as northeastern region is concerned, there's all these areas in red is indicated with that. And this is the total scientific strength and total administrative strength that we have as far as GSI is concerned. Okay, so that was it. And now, coming on to the geology of Bihar, for which I'm here, and which was a basic purpose. I've taken half an hour of time, but I'll try to speed up now here with the permission of Atul sir. And this is, you can see, this is the Regional Geological Map by Chatterjee and Ghosh of 2011. Now, if you look at this area, this particular central, the Chittanappa Nyc Complex, it's basically predominantly an amphibolite to granulite facies rock, which is juxtaposed between two low-grade mobile belts, mainly the North Singhu mobile belt in the south and the Mahakoshal mobile belt in the north. So this is the Mahakoshal mobile belt here, and the CGC is basically east-northeast and west-southwest trending high-grade metamorphic belt. Terrain in the eastern part of Central Indian Tectonic Zone, which we understand is CITZ, as you can see here in the map, and the exposed area forms a part of the northern part of the CGC. It comprises the Bihar Mica belt, which is somewhere here, and Munger group here. This is the Munger group, and the Rajgir Gaya sub-basin, and we have the Barabar Nagarjuni complex, which is somewhere here. All these isolated patches that you can see. So if you see the basic lineament pattern here, the lithological structural characteristics in Munger and Rajgir Gaya meta sediments were correlated with the Mahakoshal group of rocks. If you see the continuity out here, this is continuing out here. So basically we are of the opinion that these conjugate features or the shear zones are East Patna Fault and Munger Sasa Ridge together form a graben, which is possibly a northeastern extension of the Son Narmada graben. So this is the basic idea of geology of Bihar, but I'll gradually now go into the each and every detail as it will be relevant to you. Now, if you see, this is the geological map of Bihar and mineral resources map of Bihar. The other day in SGPB meeting, I had shared this map, and this has been updated. And one of these maps is also there in your library. And Atul sir has taken efforts to give it a very prominent location. And once we share this map also with you, it will be very useful to you to know the basic mineral occurrences. So if you look at the map of Bihar, the state of Bihar has an area of around 94,000 square kilometers. Now, out of which only 7,000 kilometers, that is about 8%, is occupied with hard rocks. Now, the remaining area is all covered under alluvium or the sediments of Indo-Gangetic Plain. So that's a very, very huge area which is under the colossal cover of alluvium. So this was the main reason that we started focusing on the remaining outcrops which were still available to Bihar, because rest everything went to Jharkhand. So that became one of the main reasons in the last decade or so to concentrate on all those areas which have never ever been emphasized, because entire focus or onus lied in the work that was to be carried out in Jharkhand. So if you see physiographically, the states can be divided into 4 major subdivisions. And here, if you look at the geomorphology of this state, the Gangetic alluvial plain lies between the Chittanappa Nyc Complex and the Himalayan foothills, which is the foothills of the Himalayas. And basically, it is a Neogene quaternary terrace with master slope towards Ganga channel. Now, if you see all these blue, all these slope is centered towards the median drainage, which is the Ganga. And superficially, the North Bihar plains exhibit a largely flat topography. That is the relief difference in the most parts of the northern parts of Bihar, the Ganga is not much. It is very, very nominal, and it is a rather flat topography with minimal relief difference. Now, it has all come up as a combined interfluvial activity of Mahananda, Kosi, Kamlabalan, Budi Gandak, and Gandak Basin, and the channels to form the Ganga group of rivers. Now, the South Ganga, which has an opposite slope altogether. Now, all these slopes are going from north to south and ultimately debouching into River Ganga, and southern slopes are moving from south to north. So, all these are flowing from south to north and ultimately going into the River Ganga. So basically the South Ganga plains, if you can see, of course, there is a certain amount of alluvium there also, the peneplain and peneplain surfaces. These manifest a step-like valley fill configuration, which has a master slopes towards the Ganga channel. Now, if you see the major geomorphological provinces or the topographical provinces, as you can see, you can clearly see the Rohtas Plateau range, which has a maximum height of 640 meters. If you can see D here, it is basically the Rajmahal Basin or the Gondwana group, which is available out there. If you see the this portion, this is basically the thin veneer of Himalayan foothills that rise over there, and the colossal cover of the Indo-Gangetic plain that forms the Foreland Basin, and ultimately this B is the Chittanappa Nyc Complex, which extends from western part of the state to eastern boundary shared with the state of West Bengal, and the Gondwana Sediment, which occurs within the rift system, is also running in an east-west direction that lie in between the Chittanappa Nyc Complex. So if we see, now we'll go into the various domains or the various rock exposure which are there individually, so that you have a good solid idea about where it all exists. Now, the first circle that I have just shown is basically the undifferentiated Shivali group. So we have a very limited exposure of Shivalik right at the West Champaran area, that is the boundary between Bihar and Nepal. And the formation basically includes rock types like calcarenite, fossiliferous calcolutite, concretionary or spongy limestone, and we have some subgravic also, and conglomeratic sandstone, variegated clay, boulder conglomerate, etc. Now these rocks have been correlated with other formations also, like Tipam and Dehing formations of Assam, and with lower and middle and upper Shivaliks of Punjab Himalayas, on the basis of lithological similarities, paleontological records, and heavy mineral association. Now, many of the findings, recent findings, also includes in West Champaran districts that officers of GSI have found out some mammalian vertebrate, some bone fragments from middle Shivaliks, which has been found out here. Now, the second, as you can see, this is the Rajmahal or the intertrappean beds in the circle that you can see in your map, and this is basically the Gondwana supergroup of rocks, including the Rajmahal. It occupies a very limited area in the state of Bihar, and the Rajmahal formation, if you may understand, constitutes a part of the Gondwana supergroup, but overlies the Dubrajpur formation, and it places oversteps into the Barakar formation or the Precambrian basements at places also. Now, it consists of number of traps, intertrappean sedimentary beds, and these sediments which accumulated between trappa labs characterize the intervening stage of various stages of flood basalt episodes in that. So the lowest is the intertrappean bed in this region, and this comprises stratified sandstone, clay stones with sandstones, subordinate oolitic ironstone, etc., which have all been a finding of GSI in late sum on basis of systematic study which has been carried out in the area. Now, if you see, next is the Gondwana sediment. Of course, it occurs as a rift basin within the Chittanappa Nyc complex. In various stages, this Gondwana comprising of shale and sandstone is exposed over there, and it has limited occurrences, and it is exposed along the western margin of Rajmahal Basin also around the, and we also have at some places it directly overlies the Precambrian basement also. Now the Barakas are best developed towards north, while in the south the Dubrajpur Formation are observed to constitute the major portions of the Rajmahal Hills. And by some definition, by opinion of some authors, it has to be segregated or excluded from the Gondwana supergroup. But basically authors, they opine that the sedimentation in Master Gondwana Basin began in late Carboniferous period and continued intermittently into the Jurassic. So Rajmahal sequence is placed by these authors in a rather in a rift or a drift succession that overlap the continental margins during the Gondwana Rift. Now, this, as you can see, is the Rohtas or the Kaimur Plateau, and it's also understood as a Vindhyan supergroup that we have exposure over there. And as you all know, it is basically during the Mesoproterozoic times that a vast area which forms now a part of the central India or the western India came under the influence of shallow marine conditions and acted as a receptacle of huge pile of sediments that we understand as Vindhyan supergroup. Now, as far as Bihar is concerned, the easternmost part of the Vindhyan Basin witnessed sedimentation during the early stage and remained also exposed during later part of the period, and thus most of the features that were exposed remained obliterated, and therefore the sedimentary package that we have only includes the two subdivisions or the lower two subdivisions of Vindhyan supergroup, which is exposed in that area, and the sedimentary package belongs to the Semri and Kaimur groups, and mainly exposed in Rohtas and Kaimur districts, with minor variations with that of the Son Valley occurrences. Now, as we may say that we have some occurrences or evidences of Vindhyans extending into the quaternary succession of North Bihar Plain has also been reported from the Madhubani Depression, that is the Graben, and Puranpur Gandak Depression also, and in the northern and northwestern Bihar under cover of Gangetic alluvium. So there's a possibility that beneath that cover of alluvium lies the Vindhyan promontory also, so to say. Now, similarly, we have Semri group for which such investigations have been carried out in GSI and Reton Pass for Glockenetic sandstone formation, and it's a very, very important mineral, a fertilizer mineral that we have. It is found within peletic sandstone, limestone, etc., and it overlies the fawn limestone formation over here. And we have obviously details are there. Now, this is a very interesting package that you just see, and this is the Mahakoshal group of rocks. And as I shared in the first slide, this Mahakoshal group of rocks is an extension of the this is possibly an extension of the Mahakoshal group of rocks towards the western side that occurs in a more significant manner within UP. And this is basically, if we look, this is a very interesting find of Geological Survey of India, Patna, and recently a volcano sedimentary sequence in juxtaposition with the Rajgir meta sediments over an aerial length of about 40 kilometers from Bathani to Churi Jagannathpur in Gaya has been found, and the entire area has been divided into three domains: the northern domain, the central domain, and southern domain. The northern domain is basically comprising of granitoids, xenoliths, phenolithites, and mafic rocks, which are intrusive into the volcano-sedimentary sequence. The magmatic suite of rocks are best exposed in Jahanabad area. As you can see here, these are the area where it is all exposed, and this is a part of the Barabar Nagarjuni magmatic complex. And we have very good mineralization evidences and 0.8 million tons of magnetite and ilmenite that has been found associated with porphyritic biotite. The central domain, of course, was a volcano-sedimentary sequence which has pilobasalts and volcanic tuffs, rhyolites, andesites, etc., everything. And finally, the southern domain consists of the arenite or the argillaceous sequence of phyllites and quartzites, which we understand as the Rajgir fold belt. Now, we have the Bihar Mica belt. Of course, a very important sequence of arenaceous and peletic rocks comprising hornblende schist and para and orthoamphibolites. large bodies are also over there, and BMB has a geological setting distinct from the extensive magnetite suite of the Chittanappa Nyc Complex. So and finally, the Chittanappa Nyc Complex, that is the main area of interest for all of us, and hence it has a strike length of about 500 kilometers and width of 200 kilometers, and it occurs in an arcuate fashion in east-west trending linear belt, which marks the eastern continuation of the Satpura origin belt. Now, it is comfortably exposed in Gaya, Jahanabad, Aurangabad area, where most of the investigations of GSI is carrying out. Now, if we look at the mineral occurrences, I would say resources, not reserves. But yes, as you can see in the slide, all these abrasive minerals, chromite, coal, the state is endorsed with a lot of metallic and non-metallic minerals. Of course, limestone and sulfur are in the production stage, about 17,000 tons, and about 600,000 tons of sulfur. But as far as other minerals are concerned, they're all in the various stages of occurrences, and they are being identified as reserves also very soon. And GSI is constantly working on these. We have a very thin veneer in the Bhagalpur area of Gondwana, where coal has been identified in Vijayaganj area of Bhagalpur district, lignito-bituminous coal, and that is also a very good discovery within various coal seams at various depths that we are finding. So this was it as far as geology is concerned, and of course this is what GSI Patna has done over a period of times in percentage, in terms of percentage that it has found out, and these are some of the main occurrences of GSI that it has main investigations that GSI has carried out during field season 2021, and these are the ongoing items of 21-22, and these are the blocks where GSI is presently working. And you can see the mineral exploration blocks based on the reconnaissance stage and the estimation stage and the G3, G4, and G2 stage for basic commodities, with the production that has, with the resource that is available, that is well correlated with the IBM data also, is what is there for you. Right now, we'll quickly go into the some of the maps. This is the story of Glockenetic sandstones. Main work has been carried out by Mr. Avinash Niranjan, who has also given a lecture with you. And this is the area where investigations on the northern side of the Son River. And this is the area where Glockenetic sandstones of good K2O value percentage has been produced. And it is one of also the blocks which has been given out for as a composite license. Now, this is the story for these are some of the geological maps and detailed geological maps investigations that have been carried out by GSI. And of course, we can have dedicated presentations on each one of them. As far as ilmenite and magnetite is concerned, we have occurrences in Jahanabad area, in Majos area, which is turning out to be a very good deposits of a good grade of iron that we are getting out there. Now, similarly for RE group of elements, as you can see, RE forms a particular L in the periodic table. The lanthanides and the other elements which form the 17 elements which are there is RE. Of course, there are very many other RE elements as well, and rare metals, and all these investigations, and particularly the blocks have been identified. The soil sampling which has been carried out, as you can see, all these green spots clearly indicate the sampling which has been carried out in the soil horizon or the laterite horizon, which lies over the Chittanappa Nyc Complex and Dalwa block. So these are some of the maps I'm just sharing with you. I'm not going into each of detail, because this will give you an idea how systematic investigations on the desired scale that we carry out work, and this gives us a plethora of information about a particular area. Similarly, we have a very important belt called the Hesatu Belabhatan belt, basically for base metal deposits, that is lead zinc deposit, and we have certain indications over there also, and we are also going to supplement that data with geophysical mapping as well. Now, this is the laterite bauxite cover, and this is also some work we are carrying out in terms of RE mineralizations also. We are trying to identify some pegmatite bodies also, fertile pegmatites, which are yielding good RE as far as this is concerned. Now, as far as gold is concerned, that became a topic of discussion. Lately, we saw in the paper that Jammu area is producing about 44% of the gold of the country. Well, that was, I would not go into detail, but yes, GSI has done very good investigations in the last 10 years, as you can see in the screen. And this has been done in West Champaran and Ajaynagar area, that is north of Rajgir, As you can see, India, detailed sampling has been carried out in the area. We have also prepared silicon, iron, and carbonate alteration map based on our work carried out. Similarly, we have identified a shear zone in Rajgir area that is immediately north of the Rajgir Hills within the volcano sedimentary sequence. And this complete shear zone, based on the drilling data and on the sampling, it is yielding very good value of gold in that area. And of course, the fire assay results is going to prove the precision of the noble metals that we are trying to find in that area. So all these investigations are giving a lot of hope to us. Similarly, for platinum group of elements we have done, and these are some of the data of resource in million tons that GSI has found out in Bihar: Glockenetic sandstones, RE, limestone, magnetite, glockenite, magnetite again, and RE. So these are some of the aspects of mineral investigation or mission 2 activities. Yes, I would now come into detail as far as mission 4 activities are concerned. As you can see, with the median drainage in place, that is Ganga River, the north part of districts of Bihar is largely affected by arsenic contamination in groundwater, something which was occurring in traces in the early part of the century, early part of the last decade, that is around 2003 and 4, has now taken a very, very strong shape, rather adverse shape, and now millions of people, around 20 million people, are affected by arsenic, and 18 districts are completely under cover of arsenic. Now, particularly the riparian districts of Bihar along the Ganga plain is the districts which are hugely affected, and we have come to a point of unanimity that it is basically the extrapeninsular rivers which is bringing a lot of arsenic into the sediments of, and GSI with its base of investigations, its provenance studies, the drilling aspects, the speciation studies, and redox potentiometer studies, and sampling with the help of field test kit has clearly identified the morphostratigraphic control and also the affected depth which is creating this problem. Similarly, in the southern part of periplain and peneplain areas, particularly in the province of Chittanappa Nyc Complex and Bihar Mica belt, we are finding very high contamination of fluoride, and we are trying to figure out what is that particular aquifer level with the help of resistivity survey. We are carrying out what is the enrichment level of that source area and what is the malnutrition aspect which is lying in that area, which is rather aggravating the problem in terms of problem. We are also doing urban geological studies in Patna, Bhagalpur, Bihar Sharif. We have already done Sonpur, Hajipur, Bodh Gaya, etc. And this is a part of the Smart City Development Program. Apart from that, the seismic telemetry network. Now, I will just come into that detail, but as you can see, I'll share some of the slides. This is the surface map for arsenic concentration. As you can see, clearly we have identified the zone of arsenic high concentration between 20 to 40 meters, and some of the peaks or the spikes that you can see clearly indicate the enrichment level of arsenic within them. So we have also prepared some long profiles or the longitudinal profile along rivers, and along that we have carried out some drilling activities that gives us an idea about depth, how things are moving, and which are the areas which are free of arsenic and which are the areas which have high concentration of first level arsenic or the secondary arsenic. That can happen in oxic waters and on anoxic conditions also, reducing conditions also. That depends on the trivalent or pentavalent arsenic that we have in water, and we are clearly a step ahead in terms of all this work, and our department is also supporting a lot as far as that is concerned. So these are some of the program. We have also developed some box plots and whisker plots of showing the concentration level or the population or the rationality of the population, how it is behaving in terms of the scatter plot, and we have developed all these programs, and we'll be and this will be available in the report that is going to come out in due course of time. Now, similarly, we have some mitigation measures also. However, GSI is not directly involved with this, but yes, it is coordinating with other agencies like Mahavir Cancer Institute, who have come up with this idea how to prevent the deeper aquifers from getting contaminated, because there's a particular zone which is being affected more because of the arsenic. Now, that is the problem. Now, if you look at the Mission 4 proposals, we are doing all these areas have been covered up for arsenic by GSI, and we are constantly geared up to take up more areas so that a completely seamless map of the entire area is created. Now, if you see the tectonic framework of Bihar, yes, we are a vulnerable state in terms of seismic activity, right from Malda and Kishanganj in the north to in the south to Katiyar and Motihari in the north. The entire sub-basin is affected or crisscrossed by a number of oblique frontal faults which are cutting across the Himalayan range, and these are the centers of major seismic activity. And if you look at the alluvium cover of the state, this is mostly the density or the velocity is quite quite low, as in terms the amplitude increases to a major level as compared to the rock foundation, and that is what makes our state a very, very vulnerable state in terms of these studies. So these studies are also carried out by GSI in terms of active fault mapping of West Patna Fault, the East Patna Fault, the Munger Sasaraj Fault, and the collinearity of these faults with some of the major events of 1934, 8.3 magnitude, and 1988 earthquake, which is 6.7 magnitude, is something that we need to be wary about. At the same time, we need to be alert also in terms of future event, in some terms of the space or the temporal spacing that lies between two events. So these studies are being carried out by GSI. We have set up some MEQ stations also, that is earthquake recorders at Saharsa, Supol, and Birol area, and others, which are constantly trying to monitor the short period earthquakes that are happening in the event. And then we are going to establish a focal plane mechanism solution, trying to understand what are the major slip movements as far as these earthquake events are concerned. We are also indulging into some exercises related to river auditing, because there was a request which came from the state government agency, and it was basically at the instance of National Green Tribunal that we carried out this program. I was personally engaged in this program in Jahanabad area, and we have come up with some startling results in terms of how erratic mining is disturbing the fertility of the rivers, and what needs to be done in order to stop that. So we have put up a proposal, and hopefully it will be through, and we'll be taking up some other program. As you can see, these are the examples of erratic mining. There are certain conditions and stipulations by which we need to extract sand from the river, and we need to clearly identify which are the clay horizons, which are the sand horizons, whether there is ample depth to which sand can be taken out, what is the fashion in which it has to be excavated, and all these factors have been clearly elaborated in this report, which was investigated by us in coordination with CTWB and Irrigation Department. So we had prepared some L profiles also, just to see the behavior of the river, how at various junction that leads to lateral spreading, and how that can be stopped, and what are the roles of divergent structures along the flow of the river, and likewise. So this is an aspect also where GSI can develop a huge amount of information, not only with the sediment load, the sedimentology, the embankment structure, and the vulnerability of the civil structures that lie along the rivers, and so many other aspects. We are going to also get very good subsurface data down to a depth of 5 meters, which can be accomplished with the help of augering, with the help of geophysical methods, and so on and so forth. Now, this is the way forward. Priorities that lies with the GSI Patna is gold investigation, urban town planning. RE and RM has to be taken down to the next level, of course, in collaboration with Atomic Mineral Division. And yes, there are some obstacles in the way as well, but when you're dealing with nature, these obstacles have to be resolved or brought to your advantage, and that is what we are aiming at. Now, very important, sir, just I'll take more 5 minutes. I'm almost in time, sir, so that should not be a problem. Bhuvi Samvad activity.
Take your own time, Biswapriya, no problem. You take your own time. Beautiful
Yes.
presentation.
Yes, sir. So this is a Bhuvi Samvad activity, which I must say, I think I must thank Dr. Atul Aditya Pandey for taking this to next level, because had he not been there, things would not have worked out the way it has taken. And it will be a very good, these particular slides were prepared by me, and I would like to share it with the wonderful students who are a part of MSc right now, that Bhuvi Samvad activity was an initiative of Ministry of Mines, basically to reach out to academia. That is the academy, that is the supply line. You are the people who are going to become a part of these professional organizations like us, and how we need to share our knowledge base with you, that you have a better understanding of what a geologist does and what the geology contributes towards nation building. And that is the major purpose of Bhuvi Samvad. And we had made this presentation also. I'm sure some of the slides which are there from your department, from the schools also, is really going to excite you as I turn the pages. As you can see, this is the banner which you had prepared, and these are the young brand ambassadors of State Unit Bihar GSI Patna, who carried the flag of GSI and reached out to the level of academia. Not only the schools, colleges, but thousands of such programs were held throughout the country by various officers. Now, we were celebrating an year of activities on the Bhuvi Samvad that we are going to just share it with you. As you can see, this is the top echelons of the government of India, Secretary Sir, Additional Secretary, Joint Secretary, and of course it was their brainchild. But basically the idea was to create awareness about the role of GSI in nation building. And you can see these are some of the mentors who continuously worked as far as this program was concerned. And these are the officers. These are the officers who have just come out of the university like you are. And obviously, once you get through GSI or other like-minded organizations, you can get into so many similar programs that can really enhance your personality and in terms of dealing with how your work culture has to be communicated across intelligentsia, right? So these are some of the officers who had carried extensive lectures in Patna University, in schools, and Mr. Asad Raza, who is also now in central headquarters, he also carried out similar programs in Patna University. And I'll share some photographs which will really make you feel good about it. Now, you see this is the list of all the programs that were carried out by GSI and how many participants that became the beneficiaries or attended these programs and how we reached out to this program. Even I must say, and I would again like to thank Atul sir, that this is a picture of the Patna University, the first program that was held in GSI Patna, how we conceived this program in order to reach out to people. And Shri Ramesh Shukla Sahab was there at that point in time. And then Atul sir also attended this program. And Earth Interactions, this particular banner was also designed was, of course, we got very valuable inputs from Department of Geology, and these were activities that were held. And these are the officers: Himali, Sandhya, Mr. Datta, myself. And you can see we reached out to school, St. Michael's, Notre Dame, St. Karen's, and even Patna Science College. This particular hall, as you can see, we are taking an oath on that day also. And that is also a part of this program. And Atul sir is there on the screen. And similar programs were carried out with Ma Mundeshwari Central School, Bhabua, Kaimur. You can see all these students are nicely picking up the nuances of geology, getting interested in the subject. And this is something which is very fascinating in terms of making known the importance of this subject to mankind. Similarly, we had in-house lectures of Bhuvi Samvad. We had prepared some presentations also, so that the audience can associate with the subject. So this is a very, very exemplary presentation, if you can see, introducing science of geology, going back to school. So this girl is nicely trying to figure out what rock is that. And this is what the purpose of going back to schools. Now, this is a platform of interactions between students and professionals. We have made some comparative slides between geography and geology, where the difference lies, and what are the major institutions that are dealing with geology once you try to become a part of them. And these are wonders of geology, so that it excites the young minds that how these formations are found, where are these located, will I be able to see them in person? These are some things which really excite people, and that is the very purpose in which you can also contribute as a student, right? So I'll quickly run through the slides. Again, in St. Michael's School, this was done by Pavnesh, Himali, and Dhananjay. You can see how many students are nicely listening to these young ambassadors like you who have just come out of the university and trying to prophesize geological science with the young minds. So it's a very, very interesting thing that we involved ourselves into, and you can see the pictures speak for themselves. Again, this is the Radiant International School, Patna. You can see these nicely lady officers and male officers are nicely interacting with the students. And you know, we receive some wonderful questions coming up from the young minds. Particularly in school, people have a tendency to ask a lot of questions, and that really hones your skill to deal with large audiences, right? So we did some work in Anugrah Narayan College also. Madam Purnima Singh was there, and I had presented a lecture over there, and that turned out to be, that was well appreciated at that point in time. So this is it. And these are some of our young officers who are constantly in interaction with you, and we would not like this to die down in future also, because they're very excited about taking such responsibilities on their heads, on their shoulders, and this is what we try to do. So this is it, sir. This was the last slide. Gold is precious and invaluable, so is the beautiful science of geology, which defines it. Yeah.
Yes, Biswapriya, excellent presentation. And the basic purpose for which we have organized this Platinum Jubilee lecture series is being fulfilled. The students, undergraduate, both undergraduate and postgraduate students who are continuously attending this Platinum Jubilee lecture series. And we had a very wonderful lecture by you. You started with the historical significance, the establishment of GSI, and then moved on to the work done by the state unit Bihar. So really, we all have been very, very encouraging response from these students. I may take one or two questions if the students wish to ask.
Yes, sir.
Students, if you wish to ask, I may allow two questions to be answered by Biswapriya, if you all have. Because in this program, we are also having the new batch of BSc Part 1. They are also attending this program. So many of these students are known to you. You have been to our department. They have listened to your presentation at the department.
Yes, sir.
Some of them, they are new. So for the students of BSc Part 1, in the beginning, I missed to just formally introduce Biswapriya about his engagements with Patna University. But just to revive, and we all know that Biswapriya graduated from Patna Science College having geology honors. Then he migrated to the University of Delhi. He had his postgraduate degree in geology. Then he cleared the UPSC geologist examination in the year 1998. And he joined GSI at Lucknow in the year 2000. And presently he is director of Geological Survey of India at State University, State Unit Bihar. The students must have seen that there are so many missions related to the activities of GSI. Biswapriya has many years of experience in mission 4 activities, which was related to engineering geology, earthquake geology, landslide studies. Environmental geology is carrying out environmental geology studies presently also related to the arsenic contamination. So students, I'm waiting for you if you have any questions. So we had, yes, there are 2 hands raised by one Sujal. Sujal, if you wish to ask any question, you are most welcome. Sujal and Kumar Gautam, both of you have raised your hands. Or maybe by mistake you have pressed the button.
Rather, I would want to ask a question to them. Sir, did you like the presentation? Did they feel excited about it? To further their interest in geology in terms of taking it to the next level. If that purpose is solved, then obviously that was the main reason of becoming a part of it, sir. And there are many dedicated lectures also, like how to write a good report and what are the basic nuances of making a good presentation. All these aspects which really, if that interface continues to be a part of such programs, sir, obviously with your permission, sir, we can get associated with the students on a one-to-one basis also. I mean, directly in that.
Yes, definitely. So before we close the session, may I ask Mr. Bhavuk Sharma, the young faculty member of the Department of Geology, to formally propose a vote of thanks. Bhavuk ji?
सर मैं कुछ क्वेश्चन पूछना चाहती थी।
जी बोलिए।
सर मैंने अभी हाल ही में एक न्यूज़ सुना है कि एक बिहार के एक ज़िला जमुई में अभी सबसे ज़्यादा इंडिया में गोल्ड ओर के बारे में पाया गया, लार्जेस्ट गोल्ड ओर रिजर्व के बारे में। तो इसके रिगार्डिंग कुछ मतलब क्या काम हो रहा है बिहार के रिगार्डिंग, आप थोड़ा इन्फॉर्मेशन दे सकते हैं, बता सकते हैं?
बिल्कुल शाजिया बता सकते हैं। देखिए मूलतः वो जानकारी बहुत गलत नहीं है। हाँ, डेटा में कुछ ऊपर नीचे हो सकता है, बिकॉज जब भी हम प्रोडक्शन स्टेज में आते हैं, जो कि जीएसआई के मैंडेट के बाहर की चीज है, ठीक है, तो उसको जो बॉडीज देखते हैं, जैसे एमईसीएल देखता है या इंडियन ब्यूरो ऑफ माइंस, उस फिगर्स को पब्लिक तक लाने का उनका जिम्मा है, ठीक है। तो कभी कभी ऐसी प्रॉब्लम्स होती हैं कि हम मीडिया तक कुछ बात थोड़े अलग तरीके से पहुंच जाती है। हाँ, ये बात सच है कि वहाँ बहुत दिनों तक इन्वेस्टिगेशन किया गया है और अभी भी जारी है जमुई जिले में, ठीक है। और कुछ अच्छे हम लोग के पीपीवी वैल्यूज आए हैं, कुछ कॉन्सेंट्रेटेड पैन सैंपल से हमको कुछ अच्छे पीपीएम वैल्यूज भी आए थे, ठीक है। लेकिन उस तरह की इन्वेस्टिगेशंस अभी बहुत ही डिटेल्ड इन्वेस्टिगेशंस के बाद ही हम किसी निष्कर्ष पे पहुंचते हैं। और उस तरह के काम उस बेल्ट में, चाहे आप उनको प्लेसर गोल्ड ले लें वेस्ट चंपारण में, जिसमें कि काम चल रहा है और बहुत ही अच्छे रिजल्ट्स हमें मिल रहे हैं। साथ ही साथ अजय नगर एरिया जो आपके राजगीर हिल्स के नॉर्थ में है, जो आपका वोल्केनो सेडिमेंट्री सीक्वेंस के साथ एसोसिएटेड, फिलिटिक टुफ और एसिडिक टुफ फिलाइट क्वार्टजाइट के साथ है, वहां पे भी कुछ गोल्ड के अकरेंसेस बहुत अच्छे मिल रहे हैं, कुछ ओल्ड पिट्स भी हैं। तो ये एक नेसेंट स्टेज में है, हम ऐसा नहीं कहेंगे बिल्कुल गलत है, लेकिन हाँ, मूलतः उतना भी सही नहीं है जितना उसके प्रोक्लेम किया गया है। लेकिन हम होपफुल हैं कि आगे हम शायद कुछ अच्छा वहां से निष्कर्ष निकाल सके। और अगर ऐसी जानकारी किसी और एजेंसीज के पास है जो हमें दी जा सकती है, तो हमने पत्र भी लिखा है उनको, जैसे कि हमें एरिया बताएं अगर उस एरिया के बारे में, तो हम डिटेल इन्वेस्टिगेशन करें और अच्छी जानकारी वहां से निकाल के लाएं। बट हाँ, बिल्कुल खारिज नहीं करते हैं, लेकिन हाँ, जिस तरह से बोला गया है शायद वह पूरी तरह से सत्य ना हो। जी,
थैंक यू सर।
सर, देयर इज प्रशांत हु वांट्स टू आस्क ए क्वेश्चन। प्रशांत कुमार माखन, आप पूछ सकते हैं सर से क्वेश्चन।
जी प्रशांत।
अनम्यूट करके प्रशांत। सर, प्रशांत चैट में लिखा है, औरंगाबाद में मिलने वाले कुछ मिनरल के बारे में बताएं सर।
औरंगाबाद में बेसिकली आपका रोहतास और कैमूर प्लेटो है, तो वहाँ पे जो जो चीज पाए जा रहे हैं वो बेसिकली लाइमस्टोन के वहाँ पे डिपॉजिट्स हैं बहुत ज़्यादा, और खास करके हमारे पास ग्लॉकोनेटिक सैंडस्टोन, जो फर्टिलाइजर मिनरल के रूप में हम उसे मिलते हैं, उसके बहुत ज़्यादा भंडार हमें मिल रहे हैं। इनफैक्ट हमने कुछ वहाँ के ब्लॉक्स को कंपोजिट लाइसेंस के लिए ऑक्शन भी किया है और गवर्नमेंट ऑफ इंडिया को दिया है। और अगर आप इस बात को देखें तो अभी जो 100 ब्लॉक्स 14 स्टेट्स में दिए गए हैं, उनमें से बिहार का योगदान 4 ब्लॉक्स का है, ठीक है। तो 4 ब्लॉक्स में 3 आपका ग्लॉकोनेटिक सैंडस्टोन से रिलेटेड है, जो कि G4 स्टेज में ऑलमोस्ट रिजर्व स्टेट में हम उसको उनको देखा गया है। और इस तरह के प्रोडक्शंस वहाँ बहुत हो रहे हैं। और लाइमस्टोन का तो पूरा आपका बेल्ट ही है, तो वहाँ तो काफी इन्हीं कमोडिटीज पे ज्यादा काम हो रहा है। जी,
तो किसी और को कोई क्वेश्चन अगर पूछना है, लास्ट क्वेश्चन आप पूछ सकते हैं। अपने आप को आप अनम्यूट करिए और क्वेश्चन पूछ सकते हैं।
आप मेरा ईमेल भी रख सकते हैं, आप मुझसे पर्सनली मिल सकते हैं। और बहुत सारे स्टूडेंट्स जीएसआई पटना आते रहते हैं, और उनसे बात करके भी बहुत अच्छा लगता है। जो हमारे लैब फैसिलिटीज़ हैं, जैसे कि हमारे पास पल्वराइज़र आया है, हमारे पास डायरेक्ट मर्करी एनालाइजर आया है, हमारे पास पोलराइजिंग माइक्रोस्कोप आया है, हमारे पास एक्सरे डिफ्रैक्शन हैंडहेल्ड आया है। तो इस तरह की चीज़ें, आप बहुत सारी चीज़ों को इंस्टेंटली पाउडर्ड मिनरल से या सीधे रॉक स्पेसिमेन से पता कर सकते हैं। तो मैं तो आपसे ये भी रिक्वेस्ट करूंगा कि आप बात करके मुझसे फोन पे बात करके जरूर आइए और इन चीजों को देखिए कि कैसे इनको डिजायर्ड मेश साइज पे लाया जाता है, कैसे उनकी एनालिसिस होती है। इससे आपकी एक्साइटमेंट लेवल भी बढ़ेगा। इस चीजों को देखेंगे तो आप ज्यादा एसोसिएट हो पाएंगे सब्जेक्ट से। तो आप फील्ड तो अवश्य जाएं, थ्योरी भी पढ़ें, लेकिन प्रैक्टिकल चीजों को भी आके देखें, इससे बहुत मदद मिलेगी आप लोगों को। एक आईसीपीएमएस की भी बात चल रही है, विच इज अ कॉस्टली इंस्ट्रूमेंट, एमी हेड से आ रहा है, बट इट विल बी प्रोक्योर्ड वेरी सून। तो ये सबसे काफी अच्छा लोग को पता लगेगा कैसे कैसे हो रहा है काम। जी
थैंक यू सर, आपने बहुत बड़ी बात बोली बच्चों के लिए कि वो लोग आपके यहाँ विजिट कर सकते हैं, आपको कभी भी कॉल कर सकते हैं। ये बताता है कि आपका डेडिकेशन बहुत अच्छा है बच्चों के प्रति, और हम आशा करते हैं कि बच्चे भी अब आपको डिस्टर्ब भी करेंगे।
बिल्कुल बिल्कुल।
थैंक यू सर। तो सर ऑफिशियली इस क्वेश्चंस के बाद आई एम गोइंग टू गिव अ वॉट ऑफ थैंक्स. Then good afternoon everyone to the one and all present here digitally. Honorable Speaker Shri Akhouri Biswapriya sir, Director Geological Survey of India, Bihar State Unit. Respected Head Department of Geology, Patna University, Professor Atul Aditya Pandey sir. Respected Dean Students Welfare, Patna University, Professor Anil Kumar sir. And respected Head Department of Geology, Patna Science College, Professor Ravind Kumar sir, faculty members, geological professionals, and my dear students. It is such an honor for me to get the opportunity to thank you, Akhouri sir. On behalf of the Geology Department, Patna University, I would like to express my gratitude to all the teachers, students, geological professionals, and other faculty members for their presence during this holiday period to make this online lecture series of Platinum Jubilee celebration of our department a great success. I extend my gratitude to our honorable speaker, Shri Akhouri Biswapriya sir, Director, to take out his time from his busy schedule to deliver an online lecture on the topic of geology of Bihar. Thank you, sir, for elaborating geology of Bihar. You have covered almost every part of geology which is related to Bihar, whether it's Chittanappa Nyc Complex of southern Bihar or Indo-Gangetic alluvium of northern Bihar. You have discussed every aspect, whether it's tectonic, whether it's lithology, petrology, geomorphology, mapping, groundwater contamination. You have covered everything which is related to geology. I am also thankful for sharing significant geological work that have been carried out by your state unit under different missions and heads for the development of the state of Bihar. GSI Bihar State Unit contribution is highly appreciable, and your today's lecture have enriched our knowledge, particularly in respect of Bihar. In the last, I must thank the organizing team for working hard for the past few days to make this event successful, especially Umar ji and Sohan ji. And thank you everyone once again for making it a great success. Thank you, sir.
Thank
In
you.
the last, sir, we would like some.
Yes, at last, just a small token of appreciation and love to our alumnus of the Department of Geology. This is the logo which we have designed. And this is thank you, all of you.
Thank you, sir. And before closing, sir, I would like to thank Bhavuk also for those lovely words he spoke for me. And not to forget on these lines, sir, I also extend my regards to Anil sir, Ravindra sir, and all faculty members of Geology Department. And I particularly the students for being patient and listening to whatever I had to share with you. And I wish you all a very happy new year and best wishes for the coming year. Thank you, sir.
Thank you, all the best. All the best.